Okay, yeah, it should be recording now. 1 second. Okay. So, hello, welcome to the second recitation for this class. And so today we're going to be covering these things: headers, prototypes, strings in C, control flow, command line outputs, so just printing, and opening and reading files, arrays, and pointers in memory, and just a little bit of some debugging stuff. I'll just give a couple pointers. And so I was looking at the quizzes, and the last question on the quiz asked what you guys wanted to be covered more. So this is kind of how that's what I used to compile this list. So okay, so the first thing is headers in C, and so the headers that you include at the top of the file, like stdio.h or string.h, those basically just allow function declarations to be shared between C files, and you could use those functions in your program after doing that. And so the syntax is, you guys are probably familiar with it. It's just the number sign include file, and they're similar to import statements in Java, so you could kind of think of them that way. And so for function prototypes, whenever you write a new function in your programs, make sure to add the function, like the method signature at the top of the file. So here is an example. So this is the main method, and then the method add numbers was created here, and so the function prototype of this is included up here. And basically that just tells C what the parameters of that function are and the return value and all of those things. So like whenever there's a call to that function, such as over here, it can cross check it and make sure that everything's all right. And so the control flow is like it's pretty standard stuff. So there's the regular for loop and while loop and the do while loop and a switch statement. And so, and then there's also break and continue, which are also pretty useful if you need to like break out of a for loop after you meet a condition or something like that. And then, so to print to the command line, you have to use, in C, you have to use format specifiers. So whenever you print anything, if you're printing an integer, you have to do %d. A character is %c, string is %s, double is %lf, and then long is just %l. And so basically the format is you call the printf function, and and then the first argument is the string with the format specifier, and the second argument is the actual item you want to print. And so here's an example. And so if you want to print this string, instead of the %c here, it'll print the character C, and then it'll also print the new line character. And then so we have strings in C, and strings in C they're pretty different than strings in other languages, at least the way you declare them and work with them. And so strings in C are basically just an array of characters. And so a string is made up of multiple characters, and each character is a different value in the array. And at the end of the string, you have the null terminator, which is the \0. And what that does is it tells C where the string actually ends. So if you do a printf and you try to print a string, it won't. And let's say you declare an array of size 10 just to store a string of size 4, but you have the %0 at the fifth slot. It'll just print the string of size 4. And then and then we have multiple ways to declare a string in C. So you could choose either one based on what your requirements are. So the first way um, so you declare an array of empty size, and you set it equal to a string. And the second is you actually define the size, and you could see that I put the size here as 7, even though the string is only 6 characters long, because you have to make sure that you account for the null terminator at the end. So it'll be random, and then the null terminator as the 7th character. And and then we have this other way of declaring it, where you could declare each character separately, and this is more explicit in how the null terminator is there at the end. And then the last way is to just you could declare a pointer of you could declare a char pointer. And so what that'll do is it'll give you a pointer to the first index value of the string array. So if I have the string random and I declare it like this, then str is a pointer to the r character here. And so this is another way to declare strings using pointers. So this is what C is really doing under the hood. This is all kind of it's just like syntactical sugar to make it more to just make it easier to type out. And these are just some important things that you could about strings in C. And so these are the differences between declaring it as an array like this or declaring it as a pointer. And so yeah, so these are just some differences and similarities here. Let's see. So we'll get to pointer arithmetic, but so if you did a plus plus here, it doesn't actually mean anything. But if you did p plus plus here, it'll actually go to the next character in the string. But we'll get to that. Um, yeah, and you guys could I'll post these slides so you guys could refer to this stuff if you need. And then we have files in C. So you guys, for your first project, you have to do a lot of things with files, open them, and scan numbers and stuff from them. So basically, here's how to open a file. Um, so you declare a file pointer called fp, and then you use the fopen function and pass in the file path here, and then you pass in the r character. Mm, So if you do you mean if you want to declare a string using malloc? Yeah, yeah. So you would have to account for the null character. Um, yeah. So the R character here just tells C that you want to read this file, and if you type W or something, then you'd be able to write to the file. And so for reading, you can use these are the two functions that you'll probably use in this class. There's other functions used to read, but these are the two main ones we'll be using. And the first one is fgets, which kind of just stores whatever it reads into a string. And and then there's fscanf, which stores um, the data that you read into a specific into different specific variables that you wanted to store it into. And if you use fgets, it'll kind of just take the whole thing that you're scanning, put that into a string, and then you would have to uh, physically go in and, like, let's say you were scanning a row of numbers and they were space separated, and it scanned like 1, 2, 3, 4, 5, all space separated. then you would have to manually go in and split them by the space character and then put them in an array separately. But fscanf makes that a lot easier, which you guys have probably seen and when you started doing the project. And so after you're done doing whatever you need to do with the file, you can close it using fclose and just pass the file pointer into it. And on Piazza, someone was asking about um, how they might need to close the file and reopen it to read the rest of it or something like that. But I just wanted to clarify that so files, when you open them, they open as a continuous stream. So after you read a certain, like any amount of it, it'll just stop there until you continue to read it. And then you could pick up where you left off when you call fgets or fscanf next. Yeah, whenever you call malloc, you always have to free it because, or else it'll result in a memory leak. And yeah, so a lot of people had questions about pointers in the quiz that we just took. And so pointers are basically just variables that hold the memory address of another variable. Um, yeah, there are cases where using fgets would be more useful. And um, I can't think of a specific case right now, but I do remember when I took the class that for some projects I chose to use fgets over fscanf. Um, yeah, and you guys will probably see you'll probably see cases where you'll have to do that later on. Mm, yeah, so basically pointers just hold the memory address of another variable, and so basically, and everything, any variable you declare is it's stored in memory and it's stored at a specific location, and you're able to get that location in C. Um, so everything in C is passed by value. So if you declare an integer or if you just declare anything, it'll be passed by value. So basically, what it'll do, it'll make a copy of it, and like if you pass an integer, it'll make a copy of it and pass the value of that integer to another function. And if you want to make any changes to that integer, you'll have to well, if you try to make any changes to that integer in the function, it actually won't change the integer where it was originally declared. So, but if you want to pass something by reference, so let's say you have an integer x and you want to pass that to another function and change it there. So if I said integer x equals 0 in the main method, and then I called a function called change x, and I passed the pointer of x into it, and I changed it there, it would actually change the original x in the main method. And I have a demo later that we could look at, and it'll kind of clarify things, hopefully. And yeah, so to actually get the pointer, you declare a variable of the type of the pointer of the type of variable that you're getting the pointer of. So in this case, we're getting the pointer of an int. So the star denotes that this will be an int pointer. And so I just called it x underscore ptr, and I set that equal to ampersand x. And here the and sign is what references a pointer. And to dereference a pointer, we can use the star operator. And so if we had the same code and um, we wanted to dereference this xptr, then we could do int copy of x equals star xptr, and this will dereference it, and it'll hold the exact same value that your x held. And so yeah, so basically passing by reference is really useful. And so it allows you to change the value of an item from another function without it being a global or malloc item. So so if you wanted to change the values in an array in a different function, you could just pass the pointer to that array, change the values, and then you could come back to the main method and work with the new values instead of so you wouldn't have to malloc in that case, and then which would make it so that it would change from anywhere. You could simply just reference it, pass the pointer, and then work with the changed values, which makes it a lot easier. Mm. And then we have arrays, and so basically an array is declared using this syntax right here. And so the syntax is so you put the type of the array, such as int, the array name like numbers, and then you put the array size. So I declared an array here called int numbers with the size of 5. So you could either just declare it like this and it'll just be an array of size 5 that'll hold integer values, or you could declare it like this and actually give it the values. So an important thing to note is that when you declare an array in using the first method, it doesn't actually initialize the variables to anything. So it doesn't like initialize all the integers to 0. So if you try to access that array, you could just get a random number that doesn't mean anything, that was just previously stored in memory at that location. So what I like to do, just to be careful, is whenever I declare an array, um, I always put a for loop on it and just initialize every index to a certain value. Like if it's a string array or a char array, I'll just initialize it to an empty string. I don't think there are for each loops in C. I haven't used one. Maybe there are in the newer versions of C, but I have never used a for each loop in C. Mm, yeah, I'll actually go over how to, I'll do a demo on how to take values from a file and put them into an array. So we'll go over that in just a few more slides. Actually, right after this, yeah. Okay, so basically, yeah, so whenever you declare an array like this, the first variable of an array holds, or the variable of an array, the variable name, such as numbers here, holds a pointer to the first element of the array. So based on that, so here's one way to access the elements of an array. So you could do int val equals numbers at 2. So it'll give you whatever's at index 2. Like for in this case, it would just be the number 3. But this is just syntactic sugar, so this just looks a lot prettier. Um, and if you wanna, what C is actually doing under the hood here is it takes numbers, which is a pointer to this first value over here, and it adds 2 to that pointer, and then the pointer is over here at this value, and then it uses the star operator to dereference that and brings the value for you. So this would also result in 3. So this is equivalent to this. Yeah, this also applies for char arrays. Any type of array, the name of the array is a pointer to the first element of the array. Yeah. Okay, so now we could take a look at. mm, you don't actually have to. You don't have to uh, specifically say how many bytes you're adding to it. C automatically does that based on what kind of array it is. So in this case, it's an integer array, and so C knows that, let's say on a specific system, integers are stored in 4 bytes. And if you do numbers plus 2, it'll add 4 bytes and then another 4 bytes because integers are 4 bytes. But if you have an array of something with 8 bytes, that takes up 8 bytes. It'll if you do numbers plus one, it'll add 8 bytes automatically. Um, yeah. So if you, it doesn't malloc it. So when you declare an array in this way, yeah, the numbers variable here is a pointer, but you have to malloc it yourself. And I'll go over right now in the demo how, or I'll go over that after we go over the malloc slides. Um, yeah. So for now, let's just take a look at the demo and let me share my VS Code. Okay, so can you guys see my code here now? Okay, cool. Um, all right, so what I did here is I have this text file, right? It's called nums.txt, and the first number of this text file is how many numbers I have in the second row, and the second row is just all of the numbers separated by a tab. And so now what I want to do is take an array and store all of these numbers into that array. So basically, um, here I have my main method, um, and so first what I do is I open the file, and so I declare the file pointer, and I use fopen to open the file that I pass as an argument to this function. Um, so if I lose you at any point throughout this code, just let me know and I'll explain it in more detail. And then I just have an if statement here that says if the file pointer equals null, then I just print file error and I return 0 because then there's nothing to do. And so then what I do is I read the first number from the file. So I declare an integer. I call it num count, which is just a count of how many numbers I'll have. And I call fscanf. And the first thing that goes into fscanf is the actual file pointer that I declared up here. And the second thing is the kind of string I'm reading, and I'll be reading integers. So I did %d, and the the last thing here is a pointer to the variable that I want to store it in. So the variable storing it in is called num count. So the third thing I pass in here is the and sign next to num count, which references the pointer a bit. And then I'm just gonna print out what num count is. And so I'll just show you that real quick, and then we could move on. So I'll kind of just comment out the rest of this code for a second, and then we could just run that part. So if I mm, yeah, whenever you scan from a file, you should like if you want to scan the num count, you should declare, like if you want to scan this first character here and store it somewhere, you should define this and then store it into that. And yeah, so right now this is the only part of the program that's going to run, opening the file and scanning the integer in, and then it'll just print the integer that was scanned. So I have this make file here, and so I'm going to use the make file to compile my program. So I'm just going to type make, and it should do that. And now I can just type /example to oh, I didn't pass in which file I wanted to read, so it gave me a file error. So let's say, so I'm gonna pass in the file nums.txt, and there we go. And now it printed out num count, and then I had the format string %d, and it printed out num count. So, uh, so that worked. And then now we could go on with the code. So, so the next thing I want to do is I want to uh, scan the rest of these and all of these numbers and put them into an array. So what I'm going to do, I'm going to declare an array. And right now I'm doing it without using malloc. And so I'm just going to declare an array called numbers, type int size 5. And I'm going to initialize all of the values of it to 0, which is just what I like to do, just to keep it safe. Yeah, so this is just a for loop running on numbers, and it just sets everything to 0. And then um, instead of 5, oh, over here, yeah, good catch. That would actually make more sense. That's the reason we actually got num count. Yeah, I kind of hard coded it. So yeah, that makes more sense. Okay, so mm, so now this is the actual loop that runs to read the numbers. So what I'm doing is I run a for loop starting at I equals 0 on up to num count, because that's how many numbers there are. So that's how many times fscanf needs to be called. And then I call fscanf, I pass in the file pointer %d. And then what I'm doing here is, so I want to store the numbers at I, right? But I can't pass in numbers at I. I need to pass in the pointer to numbers at I. So I just dereference numbers at I, and I store it in there. And then I just print out the value after storing it. And we could get rid of this because that's not, I'll go over that later. And so let me run this program. And so we could see that it did exactly what we wanted. It just printed out, it stored everything here into numbers at 0, 1, 2, 3, and 4. And it printed all of them out. And we could see that here with the tab separated. And then I just had the print new line. So that's how you read, open, read from, and scan a file. And so the rest of the stuff I have in this code, I'll go over after going over a couple more slides. So we're initializing the values to 0 because initially C won't necessarily set them to 0. So it's just better because if you're debugging and just printing out what values, so let's say I didn't do this, and then for some reason here I wasn't getting the right values that I wanted, and then let's say I was just printing some random weird values, um, I would be really confused about what's going on. But if I know that I set them to 0, then I know where those values are coming from, and or else the values could just be like 2 million or just some random value. No, the value at the 0th index won't be 5. So basically, the value at the 0. Okay, so we first what we did was read this number, and this number already got stored in num count. So next time we call fscanf, it'll start right after that. So next time we call fscanf, it'll start reading from right here. And when it does that, it'll store this first number here into numbers at 0 because I is initially 0.
So each time you call num count, it moves on to the next, like whatever's the next thing in the file.
What do you mean each time I call num count? Each time I call
Is num count a command, or is that?
No, num count is just an integer that I stored.
Oh, each time you write fscan then.
Yeah.
fscan
Yeah.
f, it reads the next whatever the next like text chart is.
Yeah, the next yeah, the next number in the file.
All right, so it skips over the spaces also.
Yeah, it does all of that for you.
Okay.
It's only looking for numbers because we specified that it's %d.
Oh, okay. Okay.
Yeah. Can you go over why we use and? Okay, so um so that's just how like when C was written, that's just how it's supposed to be. So fscanf is basically a function that the third parameter where you want to store something, you have to pass in the pointer of the variable that you want to store it in. So I want to store it in num count, but I don't actually just pass in num count. I pass in the pointer to num count, and that's just how fscanf works. And we did the same exact thing here. So you want to store the value in numbers at I, but we can't just straight up put numbers at I here. So we have to use the and operator um, to pass the pointer to that to fscanf. Yeah, that's just like the like C syntax. Mm, okay, so now I'll go back to the slides. And okay, can you guys see the slides? Okay, cool. So now the next thing I have here is I want to go over stacks and or the stack and the heap part of the memory. And people said in the quiz that they were confused by that. Mm. So basically, whenever a program runs, there's a bunch of stuff that happens. So it stores all of this different data for the program, but we don't have to worry about any of this. But and then there's two parts of the memory that you have access to, which is the stack and the heap. So the stack is so whenever you just declare a variable using just if you just type int x or char y or something like that, that goes into the stack. And so if so once a function where you declare those variables in exits, um, all of those values are kind of they just disappear. But if you want something to stay available even after a function exits or something, you can actually store that in the heap part of the memory. And the heap part is where um, the dynamic data is stored. So when we use malloc, that's where it stores your variables. So I have more on this here. So basically, when a function is called, an activation record for that function is created, and it's stored in the stack part of the memory. And that activation record keeps track of the function's parameters, variables, return value, all of those things. And so when a variable is declared in the function, it becomes part of that stack frame, the activation record. So and when the function exits, that stack frame is popped from the stack, and the values and the variables are they disappear, they're deleted. So now um, we want something where we could store those values in memory and use them in a different function without returning them or something. So that's where the heap comes in. And so the heap is the part of the memory that keeps track of the dynamically allocated memory. And we use the malloc function to allocate memory in the heap. And so this function can be called from anywhere in the program to allocate heap space. And so if you store a variable in the heap or change any of these variables that are stored in the heap, these malloc variables, um, they don't go away when a function call exits because it's not actually part of that function stack frame. When you malloc it, it becomes part of the heap. So even if the function exits, it doesn't matter. The variables stay. And then, so a downside of this is kind of that because those variables don't get deleted automatically after the function exits. You have to free those variables from the memory yourself. The unused memory. Um, do you just mean like if you don't malloc or something and you just have unused memory in the heap um, that just was never used? Yeah, no, there's no garbage collector in C. So any memory that you allocate yourself into the heap, you have to free it and get rid of it from the heap. Um, and if you actually don't do that, it results in a memory leak, which is some of the errors you guys were getting. So this is how allocation and freeing works in C. So if you want to allocate, you use the malloc function, and the malloc function takes a size and returns a pointer to a piece of memory that large. So if I give it like size of int, it'll give me a pointer to a piece of memory that's 4 bytes long if your ints are 4 bytes. So it's similar to the new keyword in Java, which also allocates a heap object. So if you guys have experience with Java and you use the new keyword, that's what that does too. And so here's an example of allocating memory in the heap using malloc. So yeah, it's a good way to think about it. And yeah, so if you wanna, so you know how we created the numbers array a few slides back using this method. Now that actually stores it in the stack. But if you want to store it in the heap, you can use this method here. And this is so now instead of um, yeah, so yeah, you would have to manually malloc both of them. So you would have to um, get heap space for both of those arrays separately. Um, okay, so you call malloc, and um, like I said, you give it a size. So let's say the size I want to give it is so I want to store, let's say, 5 integers or num count integers. That could be anything, 1, 2, 3, 4, 5, whatever. And so I want to store, let's say num count is 5, so 5 integers. And so to store 5 integers, I need space worth 5 integers. So I'm going to multiply 5 by the size of an int. So it'll actually, so if your int is 4 bytes, it'll give me 20 bytes of space. And it'll give me a pointer to an int, which will be the pointer to the first int. And similarly to this, numbers here is a pointer to the first value of the array, and um, the same way the numbers here is a pointer to the first value of the array. That's why it's also an int pointer. And then if you want to free something, you just use the free function. And so you guys have experience with Java. So Java takes care of freeing automatically using the garbage collector. And but in C you have to do it manually. And an example of this would just be to call free numbers and it frees the array. Yeah, so numbers points to the first byte, and and if you want to access something in this array, you access it the exact same way. You could just do numbers at 2 and it'll give you the value, or you could use this method and they'll both give you the exact same value. So it's not like once you actually malloc it, you use it the exact same way you use the other array, but it's useful if you want to change it in another function. Yeah, that's exactly it. It stores it in the heap, and then you have to later on free it. Um, yeah. So now I want to look at the rest of that demo, and then we can go over the rest of the code I had in there. So um, So you guys see my code now, right? Just want to make sure. Okay, thanks. Um, yeah, so if you want to create an array using malloc instead of the other method, you could, um, so let's say we don't declare the array like this, but we declare the array using malloc, which is what we just went on. This is exactly what we did. So we do int star numbers equals, and then you just cast it into an int pointer. This isn't actually necessary in C99, which is the version of C we're using, but it's still safe to do this. And then you just malloc a size that the size that the array will take up, um, of int star star. Int star star is used when you want to have a 2D array. So basically, each value of the array would point to another section. Um, so each value would just point to a row in the array. Yeah. So right now it's just pointing to each of the numbers in the array, or the first number. But if it was int star star, and then you allocated memory based on that, it would point to the first row of the array. And then everything else is literally exactly the same. So instead of declaring it like this, we just did it like this, and now everything's exactly the same. But so what's helpful here now is that we can easily, well, I could compile this and you guys will see that we get the same exact output because it's malloc and everything. And also we have to free it. And I think if we were on iLab, it would actually give me the error that it hadn't been freed. But because I'm on my own computer, it didn't. So that's the reason that you guys should run your code on iLab. Um, yeah. So now, uh, what's helpful here is that we could change the value of this array easily. So right now the array just contains these 5 elements, but let's say we want to change one of these values, then I wrote a function here. It's just called edit array, and it just takes the numbers array, which is type int star, like we see over here, and we take and it'll take an index, and it'll take the number we want to put at that index. So all this does is it takes number and makes the value at the index that you gave it the new number, and it just returns exit success. And so now we could try calling this function. So let's say we wanted to put the value 42 at the index 3 of numbers, and then I'll print what's at numbers at the index 3, and you could see that it'll change it. So we could see that at numbers 3, it's now 42. So um, if I ran this for loop again to print everything in numbers right after this, it would well, then this wouldn't be here. It would print 42 um, as the value at index 3. So yeah. So, and also when I created the edit array function, I made sure to put this method signature here, which tells you that which you just have to do because that's how the C compiler looks for it. And yeah, so does anyone have any questions about this code? Mm, okay, so I guess we could move on to the last part of the presentation that I have here, which is um, which is just a couple points on debugging. So, two good ways to debug are to use print statements and to comment code. So um, if I want to track the value of a variable and see why it's behaving the way that it is, and why um, it has an unexpected value or something, I could write print statements for that variable to see exactly how it changed and how it got to where it is. And so it allows you to track the program to see exactly where it failed. And another way is code commenting. So by code commenting, you could isolate the exact problem that you're having, and you could run the program to see if the isolated part is what's causing the issue, and then you could address that. So um, yeah, so that's basically how two simple ways to debug, and they could be really helpful. And yeah, that's the end of the presentation. So does anyone have any questions? Yeah, no problem. Yeah, if should you, um I have never used the actual debuggers offered in the editors or IDEs for C, but I've used it for other languages. But I just will go over debuggers for C. There's one called GDB, which is a popular one, and the professor's going to go over that in the future. But so you could just use these methods to debug for now. And yeah, if you guys don't have any specific questions, yeah, you could. That's the end of it. So you guys could head out. Does stack and heap memory have anything to do? No, the heap has nothing to do with the heap data structure. But I mean, um, the stack kind of manages memory the same way by pushing and popping things onto it. But we just call it that based on the pushing and popping mechanism. Arrays and pointers interchangeable. Well, the the name the variable that refers to the array is a pointer to the first element of the array. So I guess that would be the interchangeable part. Um, and oh, to comment stuff out quickly, if you press on Windows Control slash or on Mac Command slash in any sort of editor, like every editor, that's a universal thing. It'll just comment and uncomment for you. It's pretty useful. Um, what's the question number two in the first assignment? I would have to look at the first assignment. So let me. Okay, so the recitation recordings, I'll post an announcement for where you guys could find them, and it'll probably just be a new page on Canvas. And my office hours are 12 p.m. to 1 p.m. on Tuesdays, and you could find the Zoom link on the um, recitation and office hours page on Canvas in modules. Um, maximum finding the n max. Yeah, yeah. I'm pretty sure you just have to print the n maximum elements from the list of numbers that they give you. Mm. You don't have to include the assert method. And yeah, the tests will have valid inputs. I don't think you need to worry about that. Hmm. Yeah, no problem. I'll end the recording now.